Welcome to Agribiotech, a program focused on the significance of biotechnology to agricultural development in Nigeria. I am Lara Folayo. On today's edition of the program, we shall be looking at the process involved in crop genetic modification. We shall also be speaking with a scientist on what genetically modified crops are and what they are not. For now, we take a look at what's new in agricultural biotechnology around the world. A group of plant geneticists and economists say with renewed attention to implementation and regulation, new plant breeding technologies such as gene editing could make an important contribution to global food security. Their paper, published in the journal Science, suggests the new methods could reduce regulatory costs and accelerate innovation while giving several new technologies to editing genes of plant crops. They are from several institutions, including the University of Liège, Belgium, and the National Institute for Biotechnology and Genetic Engineering, Pakistan. The science paper essentially adds to existing calls for less restrictive regulations for biotechnology, advocating also for public-private partnerships and other strategies to help make plant genetic materials available to developing countries. Scientists from the University of Agricultural Sciences in India are developing tomatoes' resistance against root knot nematodes through genetic engineering. Root knot nematode is one of the serious problems in growing solanceous crops, including tomato. They introduced lectin genes from a perennial herb and soil-borne fungus into tomato using Agrobacterium tumefaciens transformation. The chain reaction showed that the transformed plants exhibited resistance with a 4.59% transformation efficiency. 3 promising events were selected and grown, then exposed to root knot nematode. High levels of resistance were observed in the transgenic plants in comparison with the non-transformed control. The scientists say the results indicate that the technology can be used for variety development of root knot nematode resistant tomatoes. American businessman and philanthropist Bill Gates has endorsed new gene editing techniques such as CRISPR, saying they could help humanity overcome some of its biggest and most persistent challenges in global health and agriculture over the next decade. Gates, in a statement, advocates the use of gene editing techniques to address pressing problems in agriculture, where the Bill and Melinda Gates Foundation has been backing research into the use of gene editing for a decade, as well as medicine. He adds that CRISPR makes the discovery and development of innovations much faster and more precise, while eliminating the most persistent diseases and causes of poverty will require scientific discovery and technological innovations. He believes it is also accelerating research that could help end extreme poverty by enabling millions of farmers in the developing world to grow crops and raise livestock that are more productive and nutritious. Food security is now a subject of global concern, with governments as well as non-governmental organizations finding solutions to an imminent global food security problem. Scientists encourage the adoption of improved technologies like biotechnology to fix the situation. They say such innovations have worked in countries with similar endowments and potentials like Nigeria. Crop modification through genetic engineering boosts the natural attributes. Countries in some parts of the world have already achieved positive impacts from this technology on their agricultural sector. Most GM crops around the globe are grown in the United States, Argentina, Brazil, Canada, and India. In the United States, for example, there are several GM crops and seeds commercially available. India, on its part, has become a net exporter of agricultural products from the use of biotechnology. The country's adoption of genetic modification launched an era of gene revolution that resulted in its becoming a major producer of the BT cotton. Brazil ranks high in tropical agriculture. This is attributed to investments in agricultural biotechnology. The country has commercialized several genetically engineered crops. Scientists feel African economies like Nigeria have a lot to learn from this South American economy where biotechnology is concerned. They advise Nigeria to employ the Brazilian genetic engineering strategy and internalize the Zero Hunger Plan to attaining food security and sufficiency. It is believed that the fast adaptation, development and commercialization of the GM technology will work positively for African economies. The international community feels potential for economic growth arising from cultivation of genetically engineered crops are massive, with increased access to food, good health and productivity. They say it will attract foreign earnings from the modern biotechnology sector, resulting in wealth creation. Science-based organizations from the international community advise that Nigeria and other African nations adopt modern-day technologies like biotechnology, using their indigenous human and financial resources to effectively address their food production challenges.
Did you know that genetically modified organisms, GMOs, are safe and do not pose any risk, hazard or danger to human, animal and the environment? Neither do they cause cancer, infertility, sterility, tumor or any adversity. There is safe use of GMO drugs like insulin, vaccine, rapid diagnostic test kits for malaria, HIV, hepatitis and so on. The safety of GMOs is certified by the World Health Organization, WHO, Food and Agricultural Organization, FAO, European Food Safety Authority, EFSA, the National Academies of Science globally, the Royal Society, UK, and over 110 prize Nobel laureates. GMOs are safe, effective, and certified by MBMA in Nigeria.
Next, I will be speaking with Onyekachi Nwankwo, the Program Officer, African Agricultural Technology Foundation, on the process involved in genetic modification for agriculture and also looking at what really genetically modified crops are. And with me on the program is Onyekachi Nwankwo. He is the Program Officer of the African Agricultural Technology Foundation, ATF, and is with me to educate us on what genetically modified crops are and what they are not. It's good to have you join me on the program.
Thank you very much.
When we say we genetically modify a crop, what exactly does that mean?
Okay, we are made up of genes in our bodies, and each gene controls a particular characteristics or trait that you see in any living organism. Now, when you modify it, it's like you are changing the sequence of the genome. I don't know how to explain that in ordinary language, but you are trying to change the characteristics to modify it in a way that it becomes more desirable, more adaptable to the environment. So now when you modify a plant, you are trying to change the characteristics of that plant in a way that it becomes more productive. In this case now, it becomes more productive. For instance, assuming, let me just use an example with a human being. Or let me use an example with a plant. Assuming a particular plant is always attacked by a disease, and you try to do everything, that disease attacks the plant. So, and you realize that that same disease does not attack some other plants. And you ask the question, why is it that this disease attacks this plant and it doesn't attack the other plant? Simply, it means that there is something this plant has that protects it from that disease that this other plant doesn't have. So now genetic modification is trying to understand, first of all, understand what is it in this other plant that makes it impossible for the disease to attack that plant. If you can identify that thing in it, and then you may be able to take it and put it in this other one to give it that protection so that the disease does not attack it. And usually we do it for plants that have major economic importance to man, in a sense to say that human beings need that crop, that plant. There are so many plants in Nigeria today, but we don't eat all of them. So there are few that we eat. And because these are food for man, for human beings, we try to do everything to protect it. So that's what genetic modification in simple terms is.
There are several misconceptions out there as to what genetically modified crops are. I'd like you to distinguish between what those crops really are and what they are not, contrary to perceptions out there.
I realize discussing with people from comments from different audiences that when Nigerians see any crop that doesn't seem to be the way it has been, they call it genetically modified. For instance, they see a mango that is bigger than the normal size, they say, oh, it's genetically modified. Or they see some fruits that you expect to see a lot of seeds inside and you don't see the seeds. They say it's genetically modified. I even heard somebody who says he went to his cassava farm and he saw a genetically modified cassava in his cassava farm, so he uprooted it. And when he said it, I laughed because I know there is no genetically modified cassava yet anywhere in the world. So these are just misconceptions that people have. Most of the things they call genetically modified are not genetically modified. But
for those crops that have some unusual traits, maybe they are usually large in size and people believe they are genetically modified, what makes them that way?
It's in nature. A lot of alterations occur. For instance, in human beings, you can see in some places they have traits for albinism. You know, this is a genetic alteration, not caused by anybody. It's there in nature. It occurs in nature, and we see albinos around. You know, so it's a genetic alteration. That's in human beings. It also happens in a lot of different organisms due to mutations. Mutations occur, you know, naturally in organisms, and mutations is due to exposure many times to different substances like ultraviolet rays, like X-rays, and different kind of things. So genetic alterations actually occur in nature. You know, but the one that we are talking about that is of economic importance is where we have been able to observe how it occurs in nature, and then instead of allowing nature to do it, which can go good or bad, we having an understanding of how it occurs in nature, you now try to use it to be able to control it, to get positive characteristics or positive traits in crops that have economic importance.
For those crops that are unusually large in size and people mistaking them for being genetically modified, what will be the difference between them and those that are actually genetically modified, in your opinion?
Now, when you are doing genetic modification, you are doing it for a particular interest. And like those crops, simple grafting and budding, those are not really, we don't consider them as, genetic modification, and they're not even regulated the way genetically modified crops are, regulated. So, ordinary conventional breeding or budding and grafting that people do can result to those better yield, but where those ones have limitation, that is where we now come in with genetic modification. And when you are modifying for a particular characteristic that you are looking for. For instance, in maize, everybody know that maize does not originate from our environment actually, and maize does not tolerate drought. Once there is some little drought, the maize plants will begin to die. Many times farmers, when it rains and they think, okay, it has started raining, they can go and plant. And after that, sometimes there could be some gap of some weeks running into months and it doesn't rain again. So the plants will begin to die. Now, and this is a very huge loss both to the farmer and to the public, because maize is a major staple food that we eat. So if it's not produced, I mean, it means famine, and it means people will begin to die. So now we see that there is no drought-tolerant maize anywhere. Now, if we now want to work on maize to make sure that it has that element of drought tolerance, to be able to tolerate mild drought. Now, you can say it is very specific. So you're going to develop the maize to be able to tolerate drought. So that's why I said that genetic modification is specific. And when you do it for maize, for example, for just that trait, it does not change any other thing about it. Every other thing remains the same. If it changes any other thing that is not what you intended it to change, it means you have to condemn it, because it simply means there are certain things not under your control. That's why we always, whenever we finish, we always try to do what we call substantial equivalence, to see that it is the same apart from the particular trait that you've added to it.
Genetic modification does not change the nutritional value of crops, except it is done for enhancement.
Yes.
We'll be talking more on that, but we have to take a quick break. And my guest is Onyekachi Nwankwo of the African Agricultural Technology Foundation. We'll take a quick break and the program will be back shortly. Do stay with us. Welcome back. The program is still Agribiotech, and Onyekachi Nwankwo is still here with me. Thanks for staying with us.
Thank you.
And just before we went on that break, we were talking about the nutritional composition of genetically modified crops. How healthy are they really for human consumption?
They do not change. The essence of substantial equivalence that we do is to check if the new product and the conventional product are the same substantially. So we expect that the only change is the change that you introduce. And you introduce this change because you're solving a problem. For instance, in cowpea, farmers who produce cowpea suffer the attack of insects, different kinds of insects. And we realize that there is no cultivar of cowpea, conventional cowpea, that has resistance to some of these insects, especially the one we are working, which is Maruca vitrata, pod borer. And so we developed a variety of cowpea. Cowpea is beans that can resist pod borer. And apart from that ability to resist pod borer in the farmer's field, it does not change any other thing. So we also try to look at the nutritional composition of both the conventional and the new product, and they are the same. It does not change it.
One of the strongest arguments in favor of genetically modified crops is that they allow for bountiful yields for the farmers. But a school of thought doubts that argument. It says the fact that a crop is genetically modified does not necessarily mean it would result in higher yields and may not mean food security for Nigeria. I wouldn't know how you would react to that argument.
Okay, like I said earlier, it depends on what you are modifying for. Giving an example with cowpea. Cowpea was modified to be able to resist certain insects in the field. Now, resisting the insect does not, in its own, give it yield advantage. But the yield advantage that comes in it comes because it is able to resist this insect. This insect will no longer attack it. And when the insect does not attack it, it will have robust opportunity to grow and to do very well. For instance, you cannot compare the productivity of a sick person and the productivity of a healthy person. Now, what we are doing is like to make sure to prevent sickness on this individual so that the individual will be able to live to its full potential. So in that case, you find out that farmers who would have sprayed a lot, yet not being able to control it 100%, will no longer spray. That is reduction of cost of production. Now, the plant itself that would have been attacked and then struggling with compensation, struggling to live, will no longer have to struggle. So it will grow well and produce well. So in essence, you find out that the yield is also increasing because of these factors. But not that a yield, not that it's a gene for yield. No, it's not. So most things that people talk about are not genetically modified. And the whole essence of genetic modification is to improve life, to improve food security. If it does not improve food security, then there's no essence doing it. And remember that farmers have choices. If a product does not meet their needs, even in Nigeria, you discover, go to many of the research institutes in Nigeria, ask them how many of their products that they have developed are in the hands of farmers. Adoption is always a challenge. And of course, if a farmer sees that this thing does not meet my need, he will not adopt it. And considering the kind of cost it takes to produce a genetically modified product, you will not, if it does not solve problems, in the first place, you will not try to invest such money, especially in cases where you are using taxpayers' money to do that. You know, you have to justify, you have to be sure that it has to improve lives.
Very quickly, just before you go, what will be your final message to Nigeria on what this technology has to offer the country?
I have been working on this for a while, and I'm also a Nigerian. So, genetic modification is for higher productivity. Nigerians should always remember that every scientific invention is trying to solve the problems of humanity. And so, genetic modification is one of those sciences, and it has worked well for a lot of other countries, and they are using it and they are benefiting from it. So Nigerian farmers should, and Nigerian public should trust their regulatory agencies and the developers established by law in Nigeria to be able to do this and do it well. And we have seasoned, well-trained scientists who are doing well everywhere in the world. And we should not be stopped from also developing our own country, Nigeria.
Thank you very much for joining me on the program.
Thank you.
And my guest has been Onyekachi Nwankwo, Program Officer of the African Agricultural Technology Foundation, distinguishing between what genetically modified crops are and what they are not, while highlighting the benefits of the technology for the Nigerian agricultural sector. After this time out, Agribiotech will be back. Do stay with us. And that brings us to the end of today's program. Send your emails to agribiotech1@yahoo.com, send us tweet at agribiotech13, or post comments on the Facebook page Agribiotech on TVC. I am Lara Folayo. Goodbye.